Welcome back everyone. In the last session we have seen question number 2 of exercise 1.2 in which we found LCM and SCF of these given numbers and we verified it with the relation LCM into SCF is equal to product of two numbers. Hope that concept was clear to you all. Now going to the third question of exercise 1.2. Okay, today we are going to learn how to find LCM and SCF again, but by applying prime factorization method. Okay, yesterday I said you that there are two methods of finding LCM and SCF. One is division method and another is prime factorization method. So before we go for prime factorization method, let's recall division method. So first question I have taken here, the first question is finding LCM and SCF of 12, 15 and 21. Okay, so let's go back to this method which you learned in your lower classes. So we'll find the prime factors of each of the numbers 12, 15 and 21 separately like this. So 2 6 times, then 2 3 times, 3 1 times, it's for 12. So we'll write the factors of 12 as 2 into 2 into 3. Then taking 15, 3 5 times is 15, 5 1 times is 1, 5 1 times is 5. So the factors of 15 are 3 into 5. Next I'll find the factors of 21, 3 7 times and 7 1 time. So 3 into 7, these are the factors of all the three numbers. Now what is SCF in this? The common one. Okay, what is common in all of them? In all these three is common. Yeah, you can check in all the numbers 3 is common. There is no other number common other than 3. So the SCF of these three numbers, that is 12, 15 and 21, is 3. Okay, what is the use of this? Like if you want to take common, this will be helpful for you. If there is an expression 12x plus 15 plus 15y minus 21z. So what can you take common from this all? You can take 3 common. Okay, because SCF is 3, so I can take 3 common from this. So remains 4x and 3 5 times 5y, and this is 3 7 times 21. Okay, 7z. So whenever we take common from any expression or any equation, we take SCF as common. Okay, so this is SCF. Next, finding the LCM. This is a well-known method to you all. Okay, you read this in lower classes. You used to find LCM. Again you have got this back in 10th class. So finding the LCM, this is division method. Okay, but our question is find by using prime factorization. Just we are recalling division method. Okay, so this is not prime factorization method. Okay, so if no method is mentioned, you can do by any method. In the exam, if we just ask find the LCM and SCF without mentioning any method name, then you can do any method which is easy for you. So this is division method. Just I am recalling, when you find the LCM by division method, 2 6 times, then 2 15 as it is, 21 as it is, 2 3 times, then 15 as it is because it won't go in 2 table, 21 as it is, then 3 1 times, 3 5 times, then 3 7 times, then 5 1 times. We'll solve it till we get 1 at the end. Now we'll multiply all these numbers, all these factors, 2 into 2 into 3 into 5 into 7. So when you multiply all these, you are getting 420. So this is LCM by division method. Now our today's concept is how to find this LCM, that is 420 okay, by using prime factorization method. How to find this LCM? By using prime factorization method, that we are going to see today. Okay, this is prime factorization method only. Okay, SCF we found by prime factorization method only. Okay, this is not division method. So let's see how to solve. So for this, I'll take question number 1 again. 12, 15 and 21. First I'll find the factors of 12. Okay, that is 2 square into 3. I'll write it in powers. Then factors of 15, 3 into 5, 3 power 1, 5 power 1. Why I'm writing in powers, you'll come to know very soon. Then 3 into 7, that is 3 power 1, 7 power 1. So finding the SCF is same like previously what we did just now. What is common in all this? 3. Yeah, 3 power 1 is common in all. So SCF, this is the statement you should remember always. SCF will be product of smallest power of each common prime factor. Okay, SCF will be the product of common factor, each common factor. What is common factor in this? 3. Common is 3, so product of smallest power of each common factor, common prime factor. So here common is 3, SCF is 3. How to find LCM from here now? That is the main concept of today's. How to find LCF? SCF you already know that we take common. Now to find LCM from these prime factors, what we must do? Let's see that now. So for that, we should take product of greatest powers of each prime factor. So we should take greatest power of each prime factor. So what are the different numbers here? 2 square. So I have taken 2 square. Then what is the greatest power of 3? It's 3 power 1 only. Okay, 3 1 times. What is the greatest power of 5? 5 only. And 7 is 7 only. So we'll take all the factors with their greatest powers, with their highest powers, and when you multiply these all, you can see you will get 420 here. Okay, so here also we did by division method, we got 420, and this is prime factorization method, we got 420. So what to do in this? You should take all the numbers, like here what are the numbers? 2 3 5 7. Yeah, in this we have 4 different numbers, 2 3 5 7. So all the numbers must be taken with the highest powers. Okay, so highest power of 2 is 2 square, 3 is 1 time, 5 is also 1 time, 7 is also 1 time. So I have taken all these and multiplied, I got 420. So this is the way we do LCM. Okay, if you practice this concept, you will be thorough in it. Okay, next I have done 2 more bits, second bit as well as third bit. Here you can see for 17, 23 and 29, these all are prime numbers, so they'll have 1 in itself as a factor. So 17 1 times, 23 1 times, 29 1 times. What is common in this? Nothing is common, only 1 is common. Okay, so prime numbers has only 1 as a common factor, or I can say 1 is the SCF for prime numbers. Okay, 1 is common in this all, so SCF is 1. Now what is LCM? LCM means you should multiply all the factors, not common. Okay, you should multiply all the factors with highest powers. So I'll multiply 17, 23, 29 and 1. So I get 11,339. This is the LCM. Okay, next one in the same way you have to do. For 8 I am getting 2 cube, for 9 I am getting 3 square, and 25 I am getting 5 square. Continuing with this, here what is common here? Nothing is common. Here only 2's, here only 3's, and here only 5's. So what is SCF, highest common factor? If nothing is common, 1 will be common. Always remember this. Then we'll find LCM. LCM will be multiplying all the factors with highest power. So what is highest power of 2? What are the numbers in this? We have 2, 3 and 5. So we'll multiply all the numbers with highest powers. Okay, like if you have 2 cube in one, 2 square in another, and 2 power 4 in the third one. So which is highest in this? 2 power 4. You must take 2 power 4. Okay, if let's take another example, if you have 3 square and 3 cube, so which is highest power of 3? 3 cube you must take. This is the way. Okay, so you must take all the numbers with the highest powers. So here I am taking 2 cube, 3 square, 5 square. Okay, they are only highest. Multiplying all of them you get 1800. So this is the way we do LCM by prime factorization method. Okay, hope it's clear to you all. The next yesterday we saw a relation SCF into LCM is equal to product of numbers. These all are important for MCQs, short answer type questions. Okay, now given that SCF of these two numbers, this is fourth question, SCF of 306 and 657 is 9. We have to find LCM, so there is no need for you to put these numbers in this way and find the LCM or do by prime factorization method. You have a relation. Okay, SCF is given to us. These are the two numbers, 306 and 657 are two numbers. SCF is given, we need to find LCM. So very simple, we can find it by using this relation also. SCF into LCM is equal to product of two numbers. SCF is 9, so I wrote 9 here. LCM, we don't know what is the LCM, so LCM as it is, and the two numbers are 306 and 657. Okay, so LCM will be 306 into 657 by 9. When you simplify it further, you'll get 22,338, and that will be your LCM. Isn't it easy? Easier than this, finding the LCM. So this relation can be used to find any one missing. Either SCF can be missing, here LCM was missing, any one number can also be missing. Okay, so you get different questions in this category. So this is all about SCF and LCM. We'll see a few application questions in the next session. Try these questions for extra practice of LCM and SCF without fail in your revision book or homework book. You can do this by both prime factorization method and verify your answer by doing it with this division method also. Okay, then see you in the next session.